Hello students, in this video I'm going to cover question number 8. So this is the question in front of you. Calculate the centripetal force. Okay, we are looking for centripetal force which is Fc m time AC. Centripetal acceleration, three types, which I told you number of times: omega square r, v omega, v square over r. Okay, we need to check which AC we are going to use it. That is called centripetal acceleration. Okay, calculate the centripetal force exerted on a vehicle of mass. Okay, mass is already given. M is your 1500 kg. That is moving at a speed. Okay, guys, now velocity is given meter per second. V 15 meter per second. This is the keyword. You need to identify omega is given or velocity is given. Okay, radius r is given. Radius r 400 meter. Which force play the role of centripetal force in this case? The first thing what we need to understand. Let's say if something is moving in circle. Let's say this is your circular path. Car is moving like this. Okay, so the one force is centripetal. So the other force which is balancing it, that is called friction force or frictional force. You need to keep this thing in your mind. Is it fine? Clear? Okay, so this is the answer. Which force? Frictional force. Okay, solve the value. So Fc is equals to m. Okay, which part of AC you will choose? We have velocity, we have radius. Velocity and radius. V square over r. Fine. Place the values. 1500 multiply. What is the V? 15 square divided by radius is 400. Okay. Solve this. 844 Newton. That is your centripetal force. Clear, guys? Fine. Okay. Now I have the second part of the question. Which of the following is a valid unit of mv omega? Okay, v and omega. We know what is AC. I told you three formulas. First is omega square r. Okay, second is your v omega, and third is your v square divided by r. So this is your v omega, which is the acceleration. Okay, so can I say this will become force m a c? Yes or no? And what is the unit of force? Newton. What is the force? What is the unit of force? Newton. That is your answer number A. Okay, the next question is, what does the blue colored arrow represent in the figure? Oh, easy. This is our Fg. Yes or no? Fg is equals to mg. This is our centripetal force which helps him to move in a circle. This is your frictional force, and this is also normal force. Normal force. And what is the meaning of normal force? Normal force means, let's say this is your surface, always 90 degree. Always, okay, take the another color. Always at 90 degree with surface. Okay, in this case, can you understand this is your surface? Yes or no? So with the surface, this makes an angle of 90 degree. This makes an angle of 90 degree. So this is your normal force. So answer A. Is it fine? Clear? Okay. Now move to the next question. This one very, very important. And what I understand, this question will definitely come. Okay, in your exam. This type or this question will definitely come. Okay, now focus. Four particles have masses in terms of m, speed in terms of v, radii in terms of r. Which of the following has least centripetal force? They can ask you the maximum also, the greatest centripetal force or the least centripetal force. We need to solve all the 4 cases. First thing, what is centripetal force? I told you FC, which is MAC. Yes or no? And AC, because velocity and radius is given, AC is V square over R. Yes or no? Okay, case number 1. Find the FC. What is the value? M is M. What is the V? V square divided by R. Is it fine? There is no change. Case number 2. Okay, FC. What is the mass? M divided by 2. Right? M divided by 2. Okay, what is the velocity? 2V. 2V square divided by R is 2R. Solve this. M over 2 multiply 4V square divided by 2R. So can I cancel 2, 2 and 4? So what I get? M V square over R. Clear? Okay, now case number 3. Case number 3. Okay, FC is equals to 2M. 2M bracket. What is the velocity? V divided by 2 square. 1 upon R is R. Solve them. 2M V square over 4 multiply 1 over R. So what I get? Okay, M V square over 2R. Yes or no? Because 2 and 4 is cancel. This and this cancel. So we get 1 over 2 bracket M V square over R. Clear, guys? Okay. 4th case, FC. What is the value of M? 3M. 3M. Okay. 2V whole square divided by 3R. Okay. 3M multiply 4V square divided by 3R. So can I cancel 3 and 3? 3 and 3 cancel. So what we get? 4 times bracket M V square over R. Clear? So this is your first case, second, third, fourth. So can I say out of 4, C part is your minimum? Yes or no? And if case 4, that is your maximum. Clear, guys? A and B are same. If you see case 1 and case 2, so can I say case 1 equal case 2. Clear, guys? Fine? Okay, you have to practice this type of question at least 2 to 3 times, because you will definitely get this type of question in the exam. Mark my words, huh? So if the same type of question will come in the exam, don't think that, okay, teacher hasn't told me. So practice this question, okay? Now move to the next question. On a curved roadway, the radius is given, okay? The radius is given, okay, fine. So the R is 100 meter. The speed limit, velocity is 16 meter per second. Velocity is given. Fine. What should be the coefficient of static friction? We need to find the coefficient of static friction between the tire and the road, so car to safely navigate the curve. As I told you, whenever car moves in a circle, in the previous question, I told you whenever the car moves in a circle, there are the 2 forces. One is friction, yes or no? And one is FC, centripetal force. And both are equal. So equate them. As we know, what is FC? M V square over R. What is friction force? Mu times of N. What is N? Or you can say mu times of mg. This is your equation number 1. Equation number 2. Solve them. Both are equal because the system is balanced. So mv square over r is equals to mu times of mg. Okay, m and m cancel. What we need to find? Mu. Mu is equals to v square over r times g. Okay, place the values. Okay, what is the velocity? Velocity 16 square divided by, what is R? 100. What is G? 9.81. So the value of friction is 0.26. And guys, remember, no unit because it's a ratio. Clear? Fine. Okay, now the next question is a plastic disc of radius r is equals to 11 centimeter. Convert this, 11 multiply 10 raised to power negative 2 meter. Okay, spinning at 90 rpm. Omega is 90 revolution per minute. Convert this, 90 revolution to radian multiply 2 pi. Minute per means divide. Minute gives you 60 second. Clear? Okay, so what you get? 90 multiply 2 pi by 60. This is your omega. What is the magnitude of centripetal acceleration? We know what is centripetal acceleration. AC. Centripetal acceleration. Okay, so what is here? Omega. What we have? R. So we have three formulas. Yes or no? V square over R, V omega, omega square R. Yes or no? So which I'm going to use? Third one. Why? Omega is given, R is given. So AC is equals to omega square R. Omega is 90 multiply 2 pi divided by 60 square multiply, what is the radius? 11 multiply 10 raised to power negative 2. Solve this fast. So the answer is 9.77 meter per second square. Guys, do you understand this point? Yes or no? Okay. Now the next question is, an object is moving in a circular path. Let's say this is the circular path. Okay. And let's say object is here. Connect this with the center. Okay. And this is your radius R. If the centripetal force, okay, we need to understand what is centripetal and what is centrifugal. This side, centripetal. This side, centrifugal. And this side we have tangential. Yes or no? Okay, tangential force. He said if the centripetal force suddenly removed means this will finish. Then what will happen? This will also finish. Which will left? Tangential. How will the object move? Very simple. Tangential. So the answer is D. Tangential from point of release. Just try to understand. One this side, one this side, and object is here, and the one force is this side. That is called tangential. Centripetal, centrifugal. So what we are removing? We are removing centripetal. So who is balancing centripetal? Centrifugal. This is also finished. So who will left? Tangential. Clear, guys? Understand? Okay, guys. So now keep on practicing and I will meet you in the next video. Till then, take care. Bye.